Hey everybody, today we are looking at Chapter 5, Section 2, which is bisectors of triangles. Starting off with some pretty important vocabulary here. When we have multiple lines intersecting at one point, so it's 3 lines or more, anytime they intersect at one point, it is called, those lines are called concurrent. Okay, so I can draw a line here, and here, and here. All of these lines, oh, that one got a little bit off, but all of these lines are concurrent and they intersect right here. Where they intersect is called your point of concurrency. All right. So what we're looking at here is in a triangle. If I draw all of the perpendicular bisectors, okay, so the red lines here are all the perpendicular bisectors of triangle ABC. We've got 3 sides, so we have 3 bisectors for each, or 1 bisector for each side, so 3 total bisectors. So those bisectors, these red lines, are going to be concurrent at point P. Point P is called the circumcenter of the triangle. All right, so your perpendicular bisectors will meet at the circumcenter. Now, what our theorem is that the distance from the circumcenter to each vertex, which is these blue lines, those are all going to be congruent. Okay, so your red lines are your perpendicular bisectors. Your blue lines are the distance to each angle, and those will be the same. When we are drawing our circumcenter and drawing our perpendicular bisectors, when I look here, if I have an acute triangle, my circumcenter is going to end up being inside the triangle. Let me Okay, so for all acute triangles, your perpendicular bisectors will meet inside it. Okay, for your obtuse triangles, your perpendicular bisectors will always meet outside the triangle. All right, so your circumcenter in an obtuse triangle is located outside the triangle. When we have a right triangle, where our perpendicular bisectors meet is on the triangle, and it's on the midpoint of the hypotenuse every single time. All right, so our circumcenter can be located inside, outside, or on the triangle, depending on the type of triangle that we are given. All right, our circumcenter, where the name circumcenter comes from, is it is the center of the circle that is circumscribed around the triangle. What that means is when you draw a triangle and you create a circle around it so that each vertex of the triangle is on the circle, just like you see here in this picture. It is said that this triangle or this circle is circumscribed about triangle ABC. And the center of that circle is your circumcenter. So your circumcenter is the center of circumscribed circles. So it's kind of a lot, but it's all the words sound very similar. So that's why it is the circumcenter. So let's take a look here for example 1. So if you have questions on any of that, go ahead and write those down now as we kind of move on here to this example 1. So we have that KZ, Z, or LZ and MZ are all perpendicular bisectors. So even though it's not marked on here, I know that this is right, and I know that these are congruent. I know that this is right, and these are congruent. I know that this is right, and these are congruent. Okay? And I want to find HZ. So if I look, HZ is right here. All right? So this piece right here is the one that I'm looking for. Okay, so HZ is the distance from the circumcenter to an angle. All right, I'm going to erase these little extra marks. Didn't mean to do that. Right there. Okay, so I know that from the circumcenter to each vertex of my triangle is going to be congruent. So all three of these are going to be the same length. So that means that HZ is going to be the same length as GZ, which is 19.9. Okay, so what I want you to do is go ahead and take a minute and try these three using this picture. So go ahead and pause your video right now. All right, so go ahead and check each of these. I know that GM is 14.5 because, again, I know that MZ is a perpendicular bisector, so this is both of these are congruent. I know GK is 18.6 because for the same reason right here, that these two sides are congruent here and here because, again, I know that KZ is a perpendicular bisector. And then I look at JZ here, which is going to be the distance from that circumcenter to the vertex of the triangle. So all three of these are congruent, so it is also 19.9. Questions on that? Go ahead and write it down now. All right, so the next thing that we're going to do is when we're given coordinates of the vertices, we are going to find the circumcenter on a graph. So we are going to start by plotting our points. So R is -6, so 1, 2, 3, 4, 5, 6, 0. So here's R at -6, 0. Okay, then S is at 0, 1, 2, 3, 4. So S is here at 0, 4. And O is at 0, 0. So here's O at 0, 0. All right, and we are going to go ahead and draw in that triangle. Okay, now, if I am finding the circumcenter, okay, that means that I am looking for two things, okay? I'm looking for the perpendicular, well, I'm looking for the perpendicular bisectors, which means I'm looking for two things, okay? I want the bisector, which means that I'm looking for the midpoint, and the perpendicular, which means that their slopes are going to be opposite reciprocals. Okay, now a lot of the times you will see your triangles looking like this, where it's kind of nice and easy. So what I want to do here is for each side, I want to find the midpoint. So 1, 2, 3, 4. This side has a length of 4. So I know this is the midpoint. This side has a length of 6. So right here is a midpoint. Now, because I know that the circumcenter is going to be where all three perpendicular bisectors meet, I really only need to draw two of them. So now I know where the point is that bisects. So what I'm going to do is I'm going to draw the perpendicular through this line. Well, since I have a vertical line, a horizontal line is going to be perpendicular to that. Okay, here I have a horizontal, so a vertical line is going to be perpendicular, and I missed, so hold on, let me just undo that. Okay, so now the question is where do those meet? They meet right here, which is at the point -3, 2. Okay, now this is also the midpoint of the hypotenuse because I have a right triangle, which is on slide 1, where we said that our circumcenter will be located anytime I have a right triangle. All right. So questions on that, go ahead and write that down now.